Hi everyone. So in this video, we're going to be discussing static electricity. So this is the first of two videos on static. And in this one, we're really going to focus on electricity and charged bodies. In the next video, we're going to be focusing on the three different ways that you can produce a static charge. To help us, we have Greg the Science Dino, who loves science, but he specifically likes to learn about electricity. So he's going to be helping us along the way to learn about electricity. Now, the first thing that we have to realize is that when we're talking about electricity, we need to actually define what the word electricity is. And electricity has to do with any phenomena that is caused by negative and positive charges. And we need to realize that this is all related back to the atom, because we know that in our atom of any material on Earth, it's made up of 3 subatomic particles. Neutrons have no charge, but there's 2 subatomic particles that have electric charges. One of them with a positive charge and one of them with a negative charge. And electricity has to do with the interaction between these charges. So to recap, if we're looking at our 2 subatomic particles, our first and probably the most important when it comes to electricity is the electron. And the electron has a negative electric charge, and it's the movement of the electron that really does define electricity. Because remember, our next subatomic particle, the proton, is stuck inside the nucleus, and it does not leave the nucleus of the atom. And this has a positive electric charge. And the differences between positively charged objects and negatively charged objects has to do with how many electrons the object has. So if a substance is a negatively charged body, it's because it has more electrons than protons. So what it means is that it's gained electrons, specifically valence electrons, because they're the only ones that really move. Our electrons that are in our inner shells, they don't basically leave the element because it's extremely stable. It's only the valence electrons, so the electrons on our outermost shell, that are the ones that are leaving or staying during our charging process. A positively charged body will have more protons than electrons. And how this happens is because a positively charged body will lose electrons, and they will lose specifically the valence electrons. And if I am losing electrons, that means I have more protons than electrons, giving an overall positive charge. Okay, so what we're actually going to be looking now for the next few minutes is what happens when you have objects with the same charge brought together and objects with different charges brought together. So what we actually have right here on the screen is 2 positively charged objects, and we're going to see what happens when you bring them together. And we can see that when you brought them together, they actually repelled each other. They pushed each other away. So now the next logical question is this a fluke? Does this only happen when the 2 charges are positive, or does this also happen when the 2 charges are negative? Let's see. So now we have 2 negatively charged bodies, and let's see what happens. And the same thing happens. So the key thing that we need to realize here is that when you have 2 objects that have the same charge, they repel each other. Now let's see what happens when we have 2 objects that have opposite charges. So what we have right here is a positively charged object and a negatively charged object. And let's see what happens when we bring them together. And they attract. So same charges repel and opposite charges attract, which is the next major thing when we're talking about electrical forces. Charges of the same sign will repel each other. So whether they're both positively charged or whether they're both negatively charged when you bring them in contact with each other, they will repel. Whereas charges of the opposite sign will attract each other. Now, all of this has to do with the law of electrical charges, which is very similar to the law of conservation of matter. And in this case, it's pretty much a subdivision of the law of conservation of matter, because we know that the law of conservation of matter is saying that matter is neither created nor destroyed. It is just changed from one form to another. Well, if we're talking about matter, matter is made up of atoms, and atoms are made up of electrons, protons, and neutrons. And the particle in the atom that can easily move would be the electron. So when we're talking about charged particles, we're talking about matter that has gained electrons to become a negatively charged object, or lost electrons to become a positively charged object. But the charge itself, the electron, isn't created or destroyed. It's just moved from one object to another. So when we're charging an object, we're basically creating an electrical imbalance in the sense that one object has a negative electric charge due to a gaining of electrons, and one object has a positive electric charge due to a loss of electrons. So we always need to remember it's the movement of electrons that causes this charge imbalance. And this is done by adding, which produces a negatively charged object, or removing, which produces a positively charged object. Static electricity. So what we've been talking about before is just basically electricity 101. When we're talking about static electricity specifically, it's dealing with electricity where my electric charges are at rest. And this basically means that I have a charge imbalance between two objects, and I don't have a circulating current of electrons, because a circulating current of electrons is dynamic electricity. With static electricity, the most important thing that we have to realize is that there are no electrons moving in a circuit, because that would be dynamic electricity, and that this imbalance is temporary. So when you statically charge something, after a while, it will lose its imbalanced charge. And it does this by two ways. The first, it loses the charge in the air. The air is a really, really good sink of electrons. The same thing with the ground. So if you were to, science trick 101, take a balloon, rub it in your hair, and then take the balloon and put it on the wall. The balloon's going to stick for about a minute, 2 minutes, and then it'll fall from the wall. Why? It's because it's lost its static charge generated when you shook the balloon on your hair. Now, the more fun and entertaining way that you lose this imbalance is through electrostatic discharge. So when you shock somebody. And the classic example, and you've probably all done this, wool socks, carpet, rub, 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 and then you touch someone and they get that zap. So this is basically the two ways that you can lose that static charge. And I think the best way to basically show this would be a classic Garfield cartoon, where we have Garfield, producing a static charge, basically, zapping everyone, and then, alas, he falls to the static as well. So I hope this helps. Make sure that you watch our second video, which talks about the 3 ways you can develop a static charge.